record. Okay, it's Thursday, so I had rainy weather. So let's see how our lecture goes today. Hopefully, I can avoid the rain since I'm outside. So, in today's lecture, we will be discussing HTTP, and I'm going to discuss HTTP in the perspective from the web client. Later, when we start developing code that will execute from a web server, we will re-examine this topic, but we will look at it from the perspective of a web server. So it makes sense, I think, to kind of cover HTTP twice from the perspective of the client versus the server. We'll look at various topics a little bit differently that way. So from the client perspective, and interesting enough, not a whole lot of great there's a lot of great data out there, but I really had to collect these slides from multiple sources to get a coherent discussion on the topic, in my opinion. So from my perspective, a good way of approaching this will be talking about the basics, then talking about URLs as they relate to HTTP, then we'll talk about the request response cycle, and then specifically we'll look at request messages, then response messages, and then once we have a good understanding of this protocol about what HTTP is, despite the fact that we use it all the time inside of our address bars, we'll take a look to see how the browser interfaces with them at the HTML level, how the browser and JavaScript allows us to essentially be a part of this HTTP protocol, and then lastly, we'll look at alternative web clients outside of browsers. So we'll cover these 8 kind of topics. And then I think on the conclusion of these 8 topics, we'll have quite a mastery of HTTP as it relates to client-side requests. So first, let's start with the basics. What is HTTP? And before we even answer that question, let's talk about the motivation behind HTTP. It's all about message passing. So at the end of the day, web applications are distributed applications. And so we have this complexity of how do we get data from one client machine to some other server machine, since that is the model we use, or more broadly, how do we get data from one machine to another machine? And so that's what HTTP provides to us. It means for web clients and web servers to pass data between each other via messages. And so let's define what HTTP actually means. It's a hypertext transfer protocol. So as you might recall, we've created hypertext markup language documents. So it seems quite apt that we have a protocol for transmitting those documents. It's an application layer protocol for transmitting our HTML content, and HTML content could be more than HTML pages. It could be like CSS pages. It could be JavaScript files. It could be images. It could be PDFs. It could be video. It could be audio. It could be anything that can get essentially delivered, any type of data. It could even be binary data that can get delivered into the browser. And so the type of media is quite extensive. So other properties we might want to consider about HTTP is it's designed for communication between web clients and web servers. HTTP follows a very client-server model where the client opens a connection to make a request and then waits until it receives a response from the server. And then finally, HTTP is a stateless protocol, meaning that the server does not keep any data or state between 2 requests. So let's talk about some of these in more detail. Application layer protocol. So in practice, there are many computers between your browser and the web server. And those might take the form of a router or a variety of routers or modems or switches or a number of things, DNS servers. But thanks to the layer design of the web, which you'll cover in extraordinarily detailed network if you haven't already taken that class, these communications are hidden to us in the network and transport layers. And so those are layers that we don't have access to in our browser, and frankly, we don't care. And that's the entire point of having a protocol at the application layer. We can rely on HTTP to take what we want to do and encapsulate those messages and send them down the network model, the OSI model of networking. And then on the web server, we are just using HTTP again to get those messages. So yeah, when you look at a computer network, there's a lot going on. When you look at the internet, there's a lot going on. But guess what? When we're building web applications, it's actually stupid simple for us because we rely on HTTP to do all of the heavy lifting for us. So as long as we understand how HTTP message passing works, then we're good. We can create these distributed applications with a very little overhead to us. So going back to this postal analogy, when we send out mail, we don't care how it gets delivered, how it gets routed between post offices. All our concerns is packaging up what we're sending, how we're addressing it, and then where to put it in the mailbox. Okay, so let's talk about client-server model. What does that mean for us? Well, HTTP is not a continuous open connection. Once the response is delivered, the connection is terminated. The connection must be initialized by the client with a request, then a response is given by the server. So I just wanted to make an additional point here, since we're talking about HTTP, that you're not bound to use HTTP for the entire duration of your web application. So you initiate contact with the server with an HTTP request. However, browsers do support alternate protocols between web servers and clients. One of the more popular ones right now are what are called web sockets. And the real distinction between WebSocket and our HTTP protocol for delivering data is WebSockets does establish a two-way continuous stream of data. So for instance, if you wanted to build an application that was like a real-time multiplayer game, you would be better off using WebSockets to exchange data between your server and your client, because the request response model would be extraordinarily slow for exchanging real-time data. So do know that there are alternatives. So when you're designing what your applications be, keep that consideration, the protocol that allows your client and your server to cross-communicate. Okay, so let's talk about what it means to be stateless. Stateless means that the server does not store information about the client in between requests. However, cookies are a way to keep HTTP both stateless, but work around this restriction of the server never remembering who you are. So in this instance of statelessness, every time the client sends a request, it could ask the server, hey, do you remember me? And the server would be like, no, I don't. What a cookie allows us to do is the server still doesn't have to store anything, but the client would send the cookie on every request to the server, which gives the server some kind of ability to ascertain how to service that request. And of course, cookie management is done on the client side by the browser. So an example of this here would be we send a request, and then the response to the web client would be to send this cookie, which would be a unique identifier. And so the next time the request is sent, if it includes that cookie, then the server can give more targeted responses. So it's kind of a way of providing statefulness in a stateless system. Okay, let's move on. So that's the basics of HTTP. So let's start about talking about web addressing, because we said it's all about message passing, and it's message passing between two different machines, a web client and a web server, or in fact, perhaps they're on the same machine. So it's two different applications. Those applications can exist on two different machines. They can exist on the same machine. One of these applications is a web client. The other one is a web server. The way that the web client and the web server interact is with a web address. And so our web address is typically going to be defined as a URL, or what we're going to call a uniform resource locator. So we'll talk more about web addresses, the parameters we can embed into a URL, anchors that we can embed inside of URL, and then the JavaScript URL API, so that this could actually be useful to us. So as I stated just moments ago, this is short for Uniform Resource Locator. It's an address of a given unique resource on the web. So anything whether it's a file, any type of file, whether it's an image file or a music file or a HTML file, they are defined as resources. So that's just a common theme. So when you go and hit for some information, when you request information, usually the concept is the most broadest of concept of a resource. And hence, with the name URL and URI and URN all end up getting their moniker for. So the makeup of a web address is the scheme, the protocol, followed by a colon, and then we do // Then we can give a domain name, and then another colon, and then the port number. The port number is not always necessary, but a lot of times when you're doing local testing, you do have to include the port that you need to listen to. The combination of the domain name and the port name are called your authority. After you have your domain name and port name, you can then have the pathway to the actual file, the resource that you're looking to access. And then you can embed two pieces of information after the actual web address. You can use a question mark and then define a set of parameters, which could also be called the query string, or it could also be called search parameters. Both names are apt. And then you can have a hashtag here, and which is essentially an ID selector in HTML, and you can provide essentially an anchor to go into a subsection of, say, for instance, an HTML document. So all of this combination is what makes up a URL, which is how we address our messages between web servers and web clients. Okay, so again, we talked about the scheme, we talked about the domain, we talked about the port, which is kind of which is a gateway into the actual application. So every application that might be networked has to be assigned a particular port number, which I'm sure you're familiar with already if you've taken networking, and again, some path to the resource on our web server. So let's talk about the more interesting things, the parameters. So URLs may embed parameters that can be provided either to the web server or the web client. Those parameters are a list of key value pairs separated with the and symbol. So notice we can have a key and then a value, and we associate the value to the key with a equal sign. We can have multiple key value pairs by combining them with an ampersand, and we initialize this sequence of parameters with a question mark. The anchor tag may embed an anchor to another part of the resource itself. An anchor represents like a bookmark inside the resource, giving the browser the directions to show the contents located at that particular spot. Really, you want to think of this essentially as an ID selector. So you can actually embed an ID selector that will jump to that particular ID, that HTML ID, inside the HTML document. Okay. So now that we've discussed the anatomy of a URL, let's talk about how we might be able to utilize this inside of JavaScript. So the JavaScript inside the browser actually has a URL API. So I want to look at the URL class. I want to look at the search params class. I want to look at the location object model that's built into the browser for us. And then I want to look at being able to encode and decode URIs. And I'll define that, but it's very similar to a URL. Just instead of a locator, you have an identifier. Okay. So we have a built-in URL class that provides an interface for easily creating and parsing URLs. So our syntax is easy here. It's just new URL. And then we can provide some string and even a base if we wanted to. So like I've done before, I create these example codes. So let me copy this example. Let's go over into our console here. And yep, we have a console about blank. So let's go ahead and take a look at what this is going to do. So here, the first thing I'm going to do is I'm going to create a variable called URL, and I'm going to assign to it an invocation to create a new URL object. And that parameter that I'm going to pass is a string that represents the URL. And then to show you some of an interesting thing we can do with the constructor, I'm then going to pass a pre-existing URL object as a second argument into the constructor, and then some alternate path that will be built off of this root path. And so my new URL should display the, it should display this alternate path that I set up. So let's see here. Let's actually go ahead and hit enter. And we see, yep, that did what it was supposed to do. So given this alternate path and this pre-existing URL object, I can go ahead and get javascript.info/profile/tester as opposed to /admin. So clear. Okay, so let's talk about some of the properties that are built into this URL object now that we've seen how we can instantiate an instance of it. We can get the protocol using the protocol identifier label. We can get host, host name, port, origin, the hyper reference, which is the entire thing, just the path name. We can get the search string, or we can get the hash string, the anchor. So again, just to prove this, let's take and actually look at this in practice. So let's jump back on over into our console. Let's paste this code. And here inside this code, let's get this to all fit. So all I'm going to do here is I'm going to create a new instance of URL, and I'm going to pass in this string. Notice the string has a protocol of HTTP. Notice this string has a host name of example.org. Notice that this string has a port number of 8080. Notice this string has a path name of home. Notice this string has a search parameter starting at the question mark of key 1 equals value 1, and key 2 is this side has equal to value 2. And then this has an anchor, which is ID selector. So I will instantiate this into URL, and then I will illustrate that URL then parses this to have all these individual attributes that I can go ahead and manipulate, read, or write into. And there we go. If I hit enter, you see I can take every one of those from the hyper reference, which is the entirety of that, to just being able to get the parameter string, or just getting the anchor value, the ID selector, or being able to just get the path name or the domain name or the protocol or any combination of those things. So very, very powerful API here in terms of managing your URLs without having to define features yourself. Okay, so more importantly, I want to look into these search parameters. So a part of this URL API is the ability to create URL search params class. And so we can invoke the constructor URL search params right here, passing some kind of query string or a search parameter string. And so recall just moments ago, right, this is what our search parameter string looks like. It starts with a question mark and then is a set of key value pairs where the key and value are delimited by the equal sign, and the collection of key value pairs are delimited by ampersand signs. Well, given that string, if I wanted to go ahead and parse that into an actual dictionary, then this is what this class is designed to do. So actually, why don't we take a look at it? Let's take this code and inspect it in real time in our console. So let's clear this out. Not really clearing that out. Okay, perfect. Let's paste this. So starting with this query, that looks just like our search string or our query string. We will pass that into the constructor of a URL search params, and that'll give us a search result here, or a search object, actually, URL search params object that I'll just call search. And then there's a number of methods that we can evoke that correspond with a dictionary. One that I'll care about is the get method. So I will get key 1 and key 2, and then console log that, and what I should get back is going to be value 1 and value 2. And in fact, when I go and execute this code, that is exactly what I'm able to do. So a very powerful way to be able to parse these from client side is to be able to use this URL search params. Again, it provides a lot of functionality that you could potentially do on your own, but you don't have to because it's built right into the browser. Okay, so what are some methods that we can use inside of our URL search params class? They have the ability to append new keys, to delete keys, to get a key, to get all the keys, to see if there has a reference to a key inside of the URL search params. You can also convert into a set or sort the keys by some kind of key value pair. So lots of different methods to be able to manage your query string or your search parameters. They're both called the same thing. Okay, so let's talk about a URL property. So we talked about the URL class. We talked about the URL search params class. The URL class actually has a property called search params that returns the search params, the URL search params on the query string. So again, let's take a look at this. I'll grab the code and actually explain it as I execute it. So let's just refresh our console there. So what are we doing here? I'm going to create a new URL object like I showed before on this line, on line 1. Here, it's just going to be the full URL string. So it's got the protocol HTTP. It's got the domain name example.org. It's got a port number 8080. It's got a path to the resource, which is going to be home. It's got our query string. That's the part I care about because that's what I'm showing you off right now. The question mark key 1 is equal to value 1 and key 2 is equal to value 2. And then I have this this anchor portion. So here I'm going to access, and actually let me cut this. Do I have to do all this at once? Oh, Lord. Okay. I'll copy and paste this. So this is fine. These things can exist because, okay. So now if I look at search, notice what search returns me is a URL search params, right? So on this URL instance that I create, it has as a parameter, this is not a function, this is not a method, this is a parameter that is a URL search params instance, which automatically gets created every time we create a URL, provided you have a query string as part of your URL. Then, once I have access to this, this is no different than instantiating my own URL search params. I can go ahead and invoke those methods, like invoking get, and then giving it a key, like key 1 and key 2, and that allows me to, let's inspect that. Key 1 has value 1, key 2 has value 2. So again, this becomes a very easy way to access this data. Okay. So what are some pros and cons of using search params? Well, we mentioned a lot about how we can do messaging between our web client and web server. And so I don't know if it's been clear about the search params, but one convenient thing about embedding the search params into your URL is that's actually a mechanism to deliver data from one machine to the other. So in other words, these query strings embedded into URL are an effective method for sending associative data to web servers or even web clients. However, it's not the only approach, as there's still HTTP messages that we're going to be talking about, the request and the response messages, which may include a body that contains the data. So here's my list of pros and cons on when you might want to use search parameters that are encoded or embedded into your URL versus using an actual HTTP request or response if you're on the web server side. But we're talking about web client perspective, so we're going to be talking about requests. So a disadvantage of using these search parameters is you should only use this for public data. This is not a secure means of transmitting private data because the data is readable. It's exposed right as part of the URL web address. So if it's anything that has to be secure, this is not the way to share it. So some advantages about this method, though, is that it's incredibly human readable. It's easy to declare and customize your parameters right off of your string. It's super easy to test because you can append your search parameters and a variety of values right inside of your web address, right inside the URL address, and submit. So it's very easy to test with. And it's actually a serverless approach to send data, which means this is actually a mechanism that allows client-to-client data transfer. And what do I mean by client-to-client data transfer? Well, recall that we can embed an anchor tag into our HTML file that hyperlinks to another HTML file. And so with a HTML file, if it's not being served by a web server, so if we're using the file protocol, we can actually still send data from one HTML page to another using this as a mechanism. So when we define an anchor tag on our anchor tag to another web document, we can embed one of these search parameter strings. And when we load to the new page, that search parameter string will be part of the URL address, which is accessible from JavaScript. So you can actually embed data from the previous page and essentially send it to the new page without having to have a web server. So to give you a use case for this, imagine that choose your own adventure story that you built for project one. You could have created directions or selections that had anchor tags that embedded data that represented choices. And that way, when you got to the new page or one of the consequence pages, you could have looked at the URL search parameters to decide what was the choice the user had selected, and then kind of process that based off of that, actually use that to make some kind of determination. Okay. So let's see, and I think I already showed that. Yeah, perfect. Okay, so the next thing I want to talk about is the location object model inside of the browser. So the location object contains information about the current URL. The location object is part of the window object, and it's accessed through the window.location property. So we have lots of values, properties that we have access to. Pretty much everything defined in a URL object is what the location object also has. So the location object is essentially a URL. And then we also have a set of methods defined inside of the location object. We can assign, we can reload, or we can replace. Let me just... Okay. Okay, so let's take a look at our location object model. Well, I'm going to grab this here. So imagine if I go to my about blank, but I'm actually going to embed a query string, and I'm going to embed a hashtag. So let's go here. And okay, so I reload. Every time I reload a new a page, it refreshes my console, which is going to really motivate us to develop what are called single page applications. So we constantly rewrite to the viewport with single page applications in order to maintain data persistence inside of our JavaScript interpreter. Anyway, so here I have my my domain name, and I have a search parameter, and then I have a anchor tag. So let's go ahead and just do a console log of location and see here when I do location, you'll see I have access to all these cool things, such as my href, which is going to be the full address in the URL bar, or I have the ability to go ahead and grab just the search parameters and then be able to use that to go ahead and build the URL search params object that allows me to parse this into key value pairs and actually use that to start processing data. So again, I can send data into my client side by embedding it into the URL string. Very, very powerful concept. Okay, and so this was the example that I want to give of how can we use this. So yeah, that's just the location object. How can we use this for a serverless approach for transmitting or sending our data? Let's go here. Okay, so here, let me give myself that key value pair. And then just to prove this concept, I'm going to copy this code, which is going to use the location object model to grab that search string. So let's take a look at each one of these lines. So I'm going to use that location object to grab the search string, convert and save that as a query string. I'm going to build a new URL search params from that query string. I'll just save that inside of what I'll call my search instance, which is my search parameters. And now that that's been instantiated, it's just like a dictionary. So I can call these the get methods on the keys and get their corresponding values. And then I'm just going to log those values here to show value 1 and value 2 was grabbed here and here. So again, great way to be able to create programmatic logic from the server or from another web client page. Okay, the last thing I want to talk about in reference to URLs is being able to actually encode and decode these URIs. And URI is just an initialism that stands for Uniform Resource Identifier. So there's a standard that defines which characters are actually allowed in our URLs or URIs, which build URLs, Uniform Resource Locators, and which characters are not. So the characters that are not allowed must be encoded. So for instance, all non-Latin characters and spaces are replaced with their UTF code, and they're prefixed with a %sign. So for instance, if you've ever seen a %20 appear inside of a URL address bar, that is the encoding for space. So we can actually take our strings and encode them based off of this URI standard. So we have encode URI, which encodes a URL as a whole. We have decode URI, which decodes it back. We have encode URI component, which encodes a URL component, such as a search parameter or a hash or a path name or something. And we can also decode that back. So let's take examples and just look at these so we can see what this looks like in the wild. Copy this, and let's go in here. Let's go ahead and... So here, I'm going to start with this text. This string contains spaces, not valid as a URI. Then I will just invoke this method, encode URI, and send that text. I'm going to get back a reformatted string that is URI compliant, and I'm going to console log that out. And so notice here, my new string is something that would be valid inside of a URL address. Okay, so why don't we do the reverse? Let's take that string and decode it back. So here, this is just the opposite. I'm going to take that string that is a URI compliant string. I'm going to decode it back into a string that is human readable or more human readable than this. And so if I console log that, I should say, yep, there it is. This string contains spaces. Not valid as a URI. Super simple, but very useful in case you want to go ahead and take advantage of these search parameters. Now let's talk about what it means to the difference between those calls and encode URI component and decode URI component. So the encode URI component encodes a URL component similar to the previous call we saw, but in addition, it also handles characters like hashtag and $ and ampersand and plus and slash and question mark, and all these are not viable characters to embed in a search parameter, in a particular component. So we can actually encode these so they can be transmitted. Let's take a look at that. So imagine if I had this string that I wanted to go ahead and make as part of my search parameters that included hashtags and $ and question marks and whatnot. Well, I can encode that using the encode URI component, and notice here it is. It encodes these with the UTF-8, prepend it with the %sign. And then just as easily, I can decode those back. And let's take a look at that. just like that. So I take this string of encoded characters and I decode them into their original text. Excellent. Okay, let me see. Make sure there's no questions here. Perfect. Okay. So an example of how we might use this to encode into a search parameter is, imagine if I had the value of rock and roll. Well, that uses the ampersand. So recall that the ampersand is typically used as the delimiter between different sets of key value pairs. So I would have to encode this. So I would invoke encode URI component to get a encoded result that I'll just call music. And then inside of this string template, I will dereference my encoded value here inside of my search parameter. And in fact, if I do this, I should then be able to console log this to be able to get an actual viable URI for search result. And there we go. And then, in fact, if I click on this, you'll see it actually produces a search result on Google. I produce a GET request that will search for rock and roll. Excellent. Let's clear that and go back to our slides. Okay, I'm done with URLs. I've talked super extensively, more so than I think any of the other similar works that I could find about URLs. But I think it's super useful because it is a mechanism that allows you to transmit data, and one we shouldn't overlook. But let's look at the more traditional way of transmitting data between a client and a server, or between two, and back from a server to a client. It's going to be through the HTTP message passing system. So I really want to talk more precisely about what it means to have this request response cycle. So you would have the browser, and it initializes an HTTP request to the web server. This request typically it's human readable. That's one of the nice things about HTTP, is that all parts of it can actually be read by a human. It's not encoded in binary or hex or anything like that. And typically, these request and response messages can be broken into three different parts. And I'll talk about this in a moment: a request line, a set of headers, and then potentially a body. And then the response back from the server to the client would be some kind of status line, a set of headers, and then whatever the content is in the form of the body. So again, a flowchart of this would look as such to compare to this diagram. So clients and servers communicate by exchanging individual messages. And again, this is as opposed to the concept of a stream of data. If you need a stream of data, then you want to use WebSockets instead. The messages are sent by the messages that are sent by the client are called requests. The messages sent back from the server are called responses. And a more technical description about what's happening is that we have a web browser. A web browser is an HTTP client. It sends requests to the server machine. And these requests are sent when the browser either tries to open a file, such as an HTML file, or opens or enters a URL address in the search bar here, and then hits enter into the address bar, or clicks on a hypertext link. All these are different ways that initializes the browser to send a request to that specified URL. And then a web server contains an HTTP daemon, which is a program that's designed to just sit there and wait for HTTP requests. It just sits and listens. And the moment that it does get an HTTP request, it handles it by issuing a response message. So the HTTP daemon receives the request and sends back the requested files or files associated with that request. Or data. It could be encrypted data as well. So it doesn't always have to have a body. Okay. So HTTP messages are how data is exchanged between a server and client. There are two types, obviously requests and responses. And they're human readable. I mentioned how they're human readable. This is what they actually look like. And again, they're divisible by three parts, right? We have the starting line on both the request and the responses, and we will break this down in the next section. And then we have the headers, which is going to be these key value pairs that gives specific data that either the server or the client needs to know. What the server needs to know this, because it's issuing this request to the web server. So this is the client giving special information that the server might want to know. And here's the header in the response message that the client might need to know to be able to establish the connection and whatnot, or for any data that's being passed to it. And then you'll have some empty line, and then finally you have your potential body, and the bodies are optional. Technically, the headers are optional as well. So you could send information inside of your request, and you get information such as actually the HTML contents as part of the body back. Okay, so let's very specifically look at a request message. So here, I want to look at our HTTP verbs. I want to look at the structure of the request message, which we just looked at briefly moments ago. And then very particularly, I want to look at what makes up the start line, what makes up the header portion, and what makes up the body portion of our request. Then, okay, so let's look at these methods, which are also typically referred to as HTTP verbs. So similar to how our spoken language has different kinds of statements, whether it's interrogative. We have informative, imperative, and interrogative. Having problems stating things today. Okay. Anyway, just as you have different verbs inside of your spoken languages, there are several types of methods in HTTP that the client can request from the server. The ones we really care about when we start designing our REST APIs is going to be a get method, a post method, a put method, and a delete method. So what do those mean? Well, get methods are the HTTP requests which a client makes to a server for getting resources from the server. So for instance, whenever you want to open Google in your browser, it makes a get request to Google server. So that's just trying to get a resource. Post methods are the HTTP requests which a client makes for sending new data to a server. So for example, when you want to add a tweet, your application makes a post request to Twitter server to actually add data, to post data. I guess it's the word post. Put methods are almost like post methods, but instead of adding information to a server, they are intended to update pre-existing information on the server. So for example, when you change your profile pic on Twitter, your application makes a put request to the server. And finally, delete is a method in HTTP requests which a client makes to delete an existing data from the server. So for example, when you delete a tweet on Twitter, your application makes a delete request to the server. So you can look at these, and for those of you who have already studied databases, you could see, oh, these are very similar to like your CRUD operations, the ability to create, read, update, or destroy or delete. And so that's fundamentally, conceptually, what we're building into with these verbs. And if you haven't taken databases, this is a good primer for it. Okay, so some considerations on these verbs, on our HTTP methods that go into our request message. So let's talk about safety. An HTTP method is said to be safe if it does not change the state of a resource when it's invoked. So get and head methods, for instance, are safe. They retrieve data, and no matter how many times they're called, the state of the resource is not changed. Post is typically an unsafe method, right? Because usually with post, you are requesting new information to get posted. Put is obviously going to be not a safe, and delete's not a safe either, because both those are changing some state inside of your server. Now, I will give a caveat that sometimes in the real world, post can actually be safe, and that's all those instances where you're using post to build complex queries for data retrieval. So one of the nice things about post is that, again, it can encapsulate typically a body, and you might use that body to build complex queries to your web server with the intent of just getting data back. So it is possible on the most technical level to build a post that is safe. But again, the purists will say that it can change the state, so you can't always rely on it being a safe verb. And let's talk about idempotent. An HTTP method is idempotent if it can be called multiple times and the end result is always the same. So get, head, put, and delete, these are all idempotent. They can be called any number of times with the same result. Notice post is not idempotent necessarily. Now, some will argue that delete is not idempotent because the second, third, and any number of following calls can result in an error message, but there are no side effects for the error message. So for all fundamental purposes, it is an idempotent call. Okay, so now let's start breaking down the structure of our HTTP request message. So once the connection is established to the web server, the user agent can send the request. And the user agent is typically a web browser, but it could be other things like a web crawler, or it could be some other alternate web client that is not a browser, like maybe Postman or Hopscotch or curl or any of these other kind of applications that can issue HTTP requests. A client request consists of some text directives, because remember, it's human readable and it's essentially produced in text. It's readable text. So it's also separated by character returns, followed by line feeds, divided into 3 blocks. The first block is a start line. That start line is going to contain the request method or the verb, followed by the parameters. It'll also have a path to the document that or the resource that you're looking to get from the server or access from the server, at the endpoint essentially. And then also, what version of HTTP are you using? Then the header is a block of text after that. So you have a character return, then a block of text. The block of text is going to be an essentially key value pair. Then you would have another character return, and then finally a body, which will be a optional block of data that would be sent to the web server to do whatever processing the web server might need to do for this request. So let's take a more let's take a diagram of that really quick. Get methods can expose some information such as passwords or user when you call for a login request. Is that considered safe method to use? So that's a good question. So you have to make a decision whether showing the username is safe or not. That is actually very common to be able to expose usernames. Those are typically commonly referred to as public data. Passwords, though, are not. Like, you should not send a password as part of the search parameter of a GET method. And if you're going to send it as a GET method, make sure that it's encapsulated inside the body. So the body is an optional part. You can send passwords through GET or POST, but just make sure it does not appear in the search parameter string. So make sure it would be encapsulated inside the message itself. Okay, so let's see here. So an actual breakdown of our of the structure that we might have would be our method, which is again our HTTP verb, our path. Here, this is just the root directory, the version of HTTP that we're using, this collection of key value pairs like host and what language, accept language, French, and developer.mozilla.org. These all represent data that will appear in the headers. So again, I think we referred to this before. You're required to have a start line, and then the other two are optional. This conveys additional information for the servers, and the body is for some methods like POST to be able to deliver data to the web server. Okay, and so here, very specifically, your start line is your HTTP method, your request target, and your version number. Don't want to spend too much time with this. I will say with your request target, it will actually just show here. Notice it does not show the domain name. It shows the path to the resource. And this would also include your search parameters. So that is important. It would include your query string so that gets delivered to your web server. Okay, let's talk a little bit about the headers. So HTTP headers let the client and the server pass additional information with an HTTP request or response. An HTTP header consists of its case and sensitive name followed by a colon, which is the delimiter, and then the value. And then white space before the value is ignored. So headers can be broken into three different types: general headers, request headers, and representation headers. And so this is just a diagram showing you the different types. Don't want to spend too much time with this because we'll kind of learn to use headers on a need-to-know basis. There could be a ton of them. And then our body, most request types don't require a body. Typically, you don't need a body for GET or delete request, but some requests send data to the server in order to update it, commonly used for post request or put request. And so there's two different types of there's two types of body for request messages: single resource bodies or multiple resource bodies. For a single resource body, it consists of a single file, and that's usually defined by the content type and the content length. So how long is the content, and what type of content is it? Is it a GIF? Is it a JPEG? Is it a TXT file? Is it an HTML file? Is it and then on a multiple resource, it is a multi-part body. So each containing a different bit of information. So again, this is typically associated with HTML forms, where with the form you might have different sets of values that's embedded within it. And so here is an example of our body. If in a human readable form of an actual HTTP message. So again, this is a request line, this is a request headers, and this might be what the message body might look like. Okay, so what are some pros and cons of this HTTP body? Well, using the HTTP response body, it is a secure means to send data from an HTTP client to an HTTP server, as the data is encapsulated into the message. However, it's not the only approach, as URLs may embed parameters. So just like we looked at the parameters, the pros and cons there, we'll look at it here. Now, again, if you're intending to send private data, typically you want to be able to use, I would recommend using post for those instances, which is why post is considered a safe HTTP verb as well. So some disadvantages, though, of using your body to send data of a HTTP request is, well, first of all, it's more restrictive to send. You have to use usually like an HTML form or a JavaScript fetch method. So you have to use some API that can send those, that can encapsulate the body of a HTTP and send that request. They're not as easy to test. You have to use some kind of application typically to test those out. You can't just use their URL address bar to send those requests. And it usually requires a server to actually receive that data. So unlike with the search parameters, where we can actually just hyperlink from one client end page to another client end page to send data from one JavaScript console into the other, potentially, these do require a server to actually receive the request and then issue a response. But advantages are it's secure, and it hides data, and it's suitable for sending both private and public data. And there's also no limit to the length of data. There's actually a limit to the search parameter string. You can't just send an unlimitedly large string, but you can parse data into chunks and send them across multiple responses. And so, and same with requests. You can chunk data into multiple requests if necessary and send large pieces of data. Okay, let's talk a little bit more about the response message. So here I want to talk about the status codes, the structure of the response message, and then those three parts: that status line, the header, and the body. So here, in the responses, when we send a request, we will get back some status code. The HTTP status code is part of the HTTP response. It helps the client understand what happened to the request. It's typically a 3-digit number, like 404, 502, which has an appropriate definition in our HTTP bias phrase. So we'll look more at the more common status codes, but understand that our status codes break into 5 primary types, all based off of the leftmost digit. So if it's a 100 number, then it means that we have an information responses. 200 numbers illustrate successful responses. 300 numbers illustrate redirect responses. 400 numbers represent client errors, and 500 responses represent server errors. So the more common ones I go ahead and define for you here. I won't go into these in detail, but you can always look this up as a resource. The ones you'll probably see most often: 200, which is an OK, successfully executed; 404, file not found, resource not found. I'm sure you've come across that multiple times. You have the 500 error, which is pretty much any broken logic inside the server. This could be anything. This is just a catch-all for a server processing problem. So you'll see this a lot. It's pretty much a meaningless error code. You're not going to, all it lets you know is that something is broken. It does not help you debug anything whatsoever. You'll see this 301. This is a redirect. Okay. So response message structures are very similar to the request structure, right? A status line, a set of headers, and a body. Don't want to spend too much time saying the same thing. Let's just kind of examine what it looks like. Since this is human readable, the first part of our status line or the response line will be the version of the protocol, so version of HTTP. Then the status code. So this is a status code that represents, hey, this was a success, your request was a success. And then finally, a status message. The status message is just a short description of the status code. And then we have the headers that send to the client that might be just additional information to know about the server. And then finally, the body, which is also optional, which is the fetch resource that might be requested. Okay, we talked all about that already. This is, and just like with request messages, response messages, they have headers, and the headers can be one of three types of header: a general header, which applies to the message as a whole; a request header, which modifies the request by specifying it further; and a representation header, which is going to be describing the encoding and format of the message body. So again, this should be very similar to general headers, applied to the message as a whole; request headers, which modify the request by specifying it further, very detailed specific to this request; and then representational headers, which describe the encoding and the format of the message body. Okay, let's go back here and go down. And then finally, we have the body. The last part of a response is the body. Not all responses have one. Responses with a status code that sufficiently answers the request do not have a need to have a payload, such as 201 created or 204 no content created. So again, responses can be defined in one of three different ways, three different parts of a response body. It could be a single resource body, which consists of a single file of a known length. And so that will typically have two headers then, the content type of what's contained in the body and the length of it. You can have a single resource body of a single file of an unknown length. And here you'll have a header that defines transfer encoding, and it'll be set to chunked. And then you can have a multi-resource body, which consists of multi-parts. This isn't used all that often, I don't think. Okay. We finally, in great detail, covered HTTP messages at both the request and the response structure. So let's talk about how we can use our browsers to actually send these HTTP requests. So browsers can send HTTP request messages. These requests may be initiated via HTML elements. So we will look at how we can initiate them from a browser perspective, from the anchor tags and iframe tags, and from forms and essentially inputs. So the browser's address bar triggers a GET request to whatever the given URL is and handles the response message. When the HTML page loads into the browser, any element that has the src attribute, the source attribute, causes the browser to issue a GET request to that given URL. So that's an instance of how HTML invokes these HTTP requests. There's additional ways after the document loads, though. We can use anchor tags to also issue a GET request. So anchors and inline frames may trigger GET requests, predominantly the anchor tags. The GET requests, the iframes do too, but they do that on load typically. So anchors hyperlink other media into the HTML document or allow you to issue a GET request. Inline frame is essentially a window inside the browser window. Iframes may be the target to both anchors and form submissions. So that's why it's worth mentioning inline frames right now, is that when we define an anchor tag, when we define a form submission event, we can target an inline frame, which is like a picture-in-picture. It's a miniature browser window inside a pre-existing browser window. We haven't used this very often, but just know that this is something that you have available. And I think it might even be in the lab. So anchor tags have the hyper reference in href. The browser sends a GET request to that URL when it's clicked. And an anchor tag can also have a target. That target is the browser window to handle the response. We can actually target an iframe. And so an iframe has a source. We already talked about how a source gets loaded, issues a GET response when it initially loads, but it could also be the target of this anchor, or it could be the target of this form. So more interesting than anchors, which just issue GET requests, we can have forms which can send GET or POST requests. Now, I can't state this enough. Forms are limited to only GET or POST requests. So even though part of the standard of HTTP is to also have delete and put requests, this cannot be handled using HTML forms. So that is a limitation of implementing forms using HTML. So forms may contain input elements that send values to the web server. A submit event on the form sends it via its action attribute and its method attribute. So looking at a form, we have the method. That's the HTTP method used to submit the form. It can either be GET or POST. You can have an action, the URL that processes the form submission. You have a target, which indicates where to display the response after submitting the form. So this could either be, by default, it's the window, the current window you're in, but you could cause it to target a new blank tab. That's what underscore that's what usually underscore tab or whatever should initialize. Or you can also give it a ID to your to like an iframe. And then the form is actually the thing that handles the submission. So when you go ahead and register with the event system in JavaScript, the submission is actually handled at the form. Even if it is the button that's triggering the event, it's actually the form element that's getting handled with it. And then the form can have a number of children elements that are inputs. These inputs are usually encapsulated into the body and sent to the web server. So typically the important attributes you want your inputs to have are going to be name, value, and potentially ID. So we've used ID before. This is the identifier used by the client to access elements inside the JavaScript interpreter. We use name to give the key name that's going to be used by the web server to label that data. So that's the distinction between name and ID. ID is for our web client. Name is for sending it to the web server. And then the value is going to be the thing that's associated to this name. And so we can actually look at that here. Why don't we take a look? I'll do this simpler one, this demo on a Google server. So let's go here. Let's refresh this. Actually, do I need to write this document? Yeah. Okay, so let me do document.write. Okay. Document.write. Okay, here I will. Okay, so here I'm just going to take a form. We'll take a look. Let me do it, and then we'll look at the elements. So here, I just have pure HTML, right? I have a form that has an action, and the action goes to the URL google.com/search, and the method will be a GET. And then here I have, get this here, and then here I have a topic, and then I'll fill out the topic. And let's see here, I have this input type. I have an ID, which is the identifier that I can access from my console with it. So again, if I type in topic, I can access that input field. The name I give it Q is what's going to be sent to the web server. So when I send this form as a GET request, it will name this input Q and give it whatever value I put into this value field here. So suppose I put in hello here as a topic. And when I hit submit here, the submit event will include everything for this form. So let's go ahead and do that. And notice what happened here was I actually sent a GET request to Google with the question of hello. That's what Q is. And so it actually did a search in Google search for hello. Perfect. So that was a GET request that then got a response from Google server and sent back a response that shows us the responses for our hello query. Oh no, why did I do that? New window. About colon. Okay. And let's open up our DevTools. That's fine. Perfect. Okay. And then we could do something very similar here. And this time we will hit up a web server that's hosted on W3 Schools called, for a service, it's a PHP service that's called Action Page. And we're just going to send it some data. So here, let's do this 2 things. We'll do 2 examples of this document about right, the Google one, and then a W3 School, just to impress upon you that we can use HTML forms to send data to web servers. So here, if I hit submit, and again, this is just some basic HTML, right? Just some input fields that have names, a submit, and we're submitting to this PHP service essentially. When I hit submit, it's going to say submitted data, and it's showing you the data that got submitted. Excellent. Okay, so let's talk about pros and cons for HTML forms. HTML forms provide a built-in approach to send HTTP request messages to a web server. However, there exist other approaches, such as JavaScript's Fetch API, which we're going to preference, and that's what you saw in the lab. And that's what you'll see in the next lab, too. The advantage of HTML forms is that they're easy to use without any JavaScript. The disadvantage is it's limited to GET and POST methods only. You cannot use delete or put methods, even though they're part of the HTTP standard. Anyway, there's lots more reasons to use Fetch. So let's talk about Fetch. So JavaScript can send network requests to the server and load new information whenever it's needed. The term AJAX, you've probably heard, is short for asynchronous JavaScript and XML. And typically it's referred to for network requests from JavaScript. So we're going to look at the Fetch API in particular. And when we look at this, we're going to look at the Fetch method, the request class, the response class, the header class, and the body class. And again, this should all be defined for you practically inside the lab. So you'll actually be touching all these technologies in the lab. So let's just talk about the AJAX model really quick. So the AJAX model involves using the web API as a proxy to more intelligently request data rather than just having the browser reload the entire page. So the way that these asynchronous calls work is that we will send an HTTP response to our asynchronous library, which will then try to request that data from the server. And when it gets that data back, it will return it back to our application. So fetching data or sending requests, as you might have realized, is asynchronous, right? Like when we send out that request, we have to wait for the server to respond before we can do anything. So we don't want our program to wait until the server responds. So when we issue that, we will wait for it to return something, and when it does, then we will execute some set of callback functions for that. And so we're going to use a special syntax called async await. Again, you should see that syntax inside this most recent lab. So let's talk about the actual fetch function that's part of the Fetch API. So this is the built-in method, fetch, which is used to send a network request and get information from the server. The basic syntax is, oh, look at this, should be await. Okay, so we will await a fetch to this URL and whatever options, like what HTTP method it might have. Simple as so. So we do URL. The URL can be either a string or a request object. If it's a request object, all of the options for the request object can be encapsulated within it. If it's a string, then we can create some option object that has the options that are required. The big one's usually the method type and whatever headers you might need to specify. Again, this is a asynchronous function whereby the client must wait for the server to send back a response. Thus, we must use the async await keywords whenever calling this function as such. And so a quick demo of this, we'll see a demo at the end of the slide section, or you can just check the lab for demos of the Fetch API. Okay, so let's talk about the classes that support the Fetch API. You have a request class. So the request class represents a resource request. You create a new request object using the constructor. And again, we do this in the lab. New request, and then whatever the input is, where the input is a string containing the URL that you want to fetch. And then you can also pass a object that defines the objects, I'm sorry, not the object, the options you want. So that could be like your method, whether it's a get or a post or a put or delete. It could be the key value headers that you want to pass along. And if there's a body, you can also include a body object. So when you produce, and we can actually look at this, we can actually very quickly build out our own request object. Let's go to the console here. Oh, let me go to my about. So here I have my options object that's going to have my method post, and then a body, which is going to have my key value pair. And then I will also have a request object, so a new request, where I will give it the URL and then this options object. And then I will be able to see it's going to parse all this such that I can check the request for the URL and the method credentials and the body use. So this gives me a very object-oriented approach of constructing request messages and prepping them to send them via fetch method to a web server. And then the response objects are not ones we're going to construct ourselves. We will typically get a response object from the web server, and it gets instantiated for us by the browser, by this Fetch API. So the response class represents the response to a request. The properties of a response are its status code, and this kind of OK message, which is true if the status code is between 200 to 299. And then we have a variety of methods that are definitely worth knowing. And again, we should cover these methods already inside of, if not this lab, the next lab. But the important ones that I would say that are worth knowing are JSON, which will parse the response into a JavaScript object notation, so as a JavaScript object. The ability to parse the response as text, so it'll read the response and return text. Or blob, which will return the result as a binary object, essentially. And again, you'll get a chance to actually use these. And then the two other supporting objects that are worth knowing is the header class. So the header class is part of the Fetch API that allows you to perform various actions on the HTTP request and response headers. And these actions might be retrieve, set, add, or remove headers from the list of the request headers. And then you can easily edit these inside of a request or response object. And then you also have the body class, which represents the response or request body. And if you want more information about the header or the response class, then I give you the actual API documentation there. So I did want to do a quick demonstration of this fetch, and I'm going to do this quick demonstration actually launching an HTTP server using Node. So this will be our first demo of Node. So here inside of my console, I'll do HTTP-server. This will have Node launch a server. Here you see I have a server listening on port 8080. Okay, so now let's go into our console and issue some of these requests. So suppose I want to use my fetch to issue a post method. So here I will go into here. Again, this is an asynchronous call, so I will preface it with an await. Then I will use the fetch method. I will fetch on this URL localhost at 8080, port 8080, and the method of request that I will have. So my verb will be a post request. So let's hit enter here. And you should see, obviously, there's nothing on my server that can actually handle this. So I'm going to get a failure. But more important, notice on the actual server, I did go ahead and receive this request. I got this post request. Excellent. And I want to illustrate the powerful thing about using the JavaScript Fetch API is besides the post and the get, which is what we're limited to from the HTML side of things, right? We got the get there. I can also do a put and delete, which I cannot do with pure HTML. And so I do want to highlight this. Yep, there's my, did I do options? Okay, let's do it clear. And finally, let's do a delete. And here, it's going to show that these right here are set as options, but then I would handle this inside of my body here, inside of my web server. But anyway, this just shows you how we're actually sending requests from our browser into this backend server here, which is also hosted on the same machine. Excellent. And so I just want to highlight that the pros and cons of using the Fetch API, it does require a little bit more programming knowledge. It requires us to understand this async JavaScript thing. But the advantage is that it's highly customizable and configurable. It's the only way for us to access all the verbs and HTTP methods. We can manage both HTTP requests and HTTP responses via our client side using this API. We can't do that with forms. And it's capable of executing JavaScript in response to a HTTP response. So we can actually do things on our client side after we get the response from the web server. So it allows us to do what is effectively building web applications. We can do that because of this Fetch API. Now, there is alternatives to the Fetch API. An alternative is the Axios, which is a JavaScript library that offers comprehensive HTTP network request and response. I will not cover this in the class, but I did want to mention it. You can find the project here on this GitHub page, so you can check it out. There's plenty of examples there. And a lot of people say that this is an easier mechanism than the Fetch API, although the Fetch API is not hard at all. It essentially compresses from 1 calls to 2. And so the last thing I want to mention before I close out this lecture on HTTP from a client perspective is just some alternative web clients. So browsers aren't the only application that can issue HTTP requests. It's just the most common. Other ones that we'll look at actually over the course of the semester are going to be ones that we can issue HTTP requests from the command line and ones that allow us to do it from a GUI perspective. So from the command line, you might have heard of a command line application called curl. So it's like a web browser, but allows us to issue these HTTP requests directly from our command line. So I would definitely encourage you to check this out and play around with it. I have a video in Moodle that is a full crash course on that. So check that out if you're interested. It's very good for testing and debugging. That's actually why we're interested in alternative web clients, is when we start testing our REST endpoints on our web server, we'll use these to see that they're actually doing what we expect them to do. And then if you want GUI variants of this, if you don't want a command line version, they have Postman, which is probably the most common means of issuing HTTP requests outside of a web server. Although there's a web application variant of this called Hopscotch, and I'll just show you Hopscotch before I close out for today, just so you can see what it looks like as an alternative to a web browser for sending these requests. So here I can change whether it's get, post, put, head. One problem you have with your address bar is it only produces gets. So these more feature-rich HTTP request web clients allow you to select what your action verb is going to be, what your HTTP verb is going to be, and then you can send to the URL to whatever that endpoint is, and notice it sends the response body here in a human readable form, and then you could read the headers, and you read all the values, and it shows you your code 200 success. So again, you could probably see how useful this is for testing purposes. And again, we'll get more into that as we actually start talking more from a perspective of the web server, not the web client. Anyway, that's everything I have to say about HTTP from a client side perspective. And this is really probably going to be, at least for now, the last lecture we're going to have on web clients until we migrate to web servers. And then we'll do some in web servers for the next several weeks, and then probably come back to web clients to illustrate using React to go ahead and develop programmatic front-end representations of our DOM. So is there any questions about HTTP in terms of being able to deliver messages between our web clients and their web servers? So now there is the lab that is due tomorrow where you get a little bit of flavor of this, and the next lab will also cover this content as well. Okay, well, if there's no questions, then I will end today's lecture. I'm really happy with where we're at, because we're right at midterm, and we've essentially covered all the core concepts we need to cover in terms of how to build applications from the front end, and now how to request data from some back-end service. So this is going to prepare us for the next homework, even though I know that we have one that's due on April 2nd. You can anticipate that the homework that's following that one will be to do something similar to what you have just done, which is to build out a web application, but to do one that actually requests data or some kind of services from some pre-existing backend server. And so I'll issue details in the future, but you'll be able to have the option of using either an API that I'll recommend or finding your own REST API that your browser app can be a client to. I think that'll be an exciting project to work on and give you a really strong understanding of how your client and how your front end portion of the application will tie into a back-end service in terms of the communication between the two. Excellent. Okay, and that's everything I have to say. I will issue the new lab sometime before the next lecture, so before Tuesday, and I'll send out an email when that happens. So let me go ahead and end the recording for today, though. Perfect.